Hi, my name is Andrew, and I'm with DesignPoint, and I'm here to talk to you today about MRO parts and why you might want to think about 3D printing them instead of having them traditionally made next time you need some. So, first, what is MRO? MRO stands for Maintenance, Repair, and Operations. This is the team that works in a manufacturing facility and is responsible for maintaining and repairing all the systems, keeping production going. So the challenges for an MRO team, typically the biggest one is time. You know, they're always up against the clock. If an important machine breaks down, it's going to hold up all production, so they have to get that machine up and running as quickly as possible. And the parts aren't always available, right? I mean, what we see in some manufacturing facilities is that they've got machines that were made 50 years ago, 75 years ago, and you know, the part breaks, they go to look up the company, and the company doesn't even exist anymore. So they can't get the spare part. Or maybe the company exists and they just don't make that part anymore because the machine is so old, they don't support it. So that's why 3D printing is actually an ideal solution for MRO, because you can make parts fast, right? This cuts down your supply chain. You've now moved your supply chain from potentially outside, if you're outsourcing, to inside. Now you have the freedom to make anything you want. So an example of an MRO part that would be kind of common, that you'd see in maybe an old machine that broke down, is a herringbone gear. So this is a herringbone gear. You can tell it's a herringbone because it's got this unique geometry on the side. And the purpose of that is that when it's engaged with another herringbone gear, it's very hard to dislodge it in this direction. Because of that unique geometry, it pulls everything to the center. So, you know, if this part breaks and you go to your internal machine shop, you know, maybe you can skip the line, maybe you can't if it's a really important part. But if you can't, you can see lead times from your internal machine shop of anywhere from 1 week to 2 weeks to who knows. And if you're outsourcing, almost certainly you'll have a lead time somewhere between 1 to even 8 weeks. Probably depends on how busy they are and how complicated of a part that you want to make for them. And of course, time is the big factor for an MRO team, but second, not too far behind, would be cost. And the cost to print this part is about $35. And I would imagine that if you went to a machine shop and you asked them to make this, this probably would be at least $100, maybe a couple hundred, maybe even more. So definitely some cost savings there as well. But when looking at time, we can produce this part right here and other parts alongside of it in about 3 days. Our printer, called the Metal X right here, it's a 3-step process. You print, you wash, you sinter. Each step takes roughly about a day. But you can batch parts in, so you can be printing this and maybe other stuff you need. You print them at the same time, wash them at the same time, sinter them at the same time. So I say 3 days to make this single part, but you'd probably be getting more value out of it in reality. So replacement parts, that's a big one for MRO. Second, custom tools could be a really good part for an MRO team. This is what's called a tamper-proof wrench. So the purpose of this is whatever this adjusts is so important and so sensitive that they want to make their own custom tool so that nobody can just walk up to it and crank that lever, whatever it is. So they make the part with a custom size in here. And what's neat about this part is that it's actually a hybrid part. So the handle's made from carbon fiber reinforced plastics. This is really strong. And then the business end is A2 tool steel. Although we have other tool steels as well. You can do A2, D2, H13, depending on what you're working with. And it's a neat design where it's got these rollers from McMaster Carr in there, so you can very easily pop out this insert, which means that as this wears out, you can very easily 3D print a replacement for this, or maybe you've got a handful of custom, levers that you don't want people to pull. So you might have a handful of these different inserts to go in your handle, and then you only need one handle, so this is modular. Also, this tool is extremely light. If this tool was made out of all tool steel, this would be much heavier, and there's some safety issues there. You drop this thing on your foot, you can hurt yourself. When things are lighter, they are safer and easier to move around and transport around your facility. Another obvious choice for MRO is brackets. brackets and mounts, there's a bunch of different reasons why they might want to use it. One, if this stuff breaks, you got to replace it, right? And it might be something custom that was made specifically for whatever you're mounting, so it might take some effort to get the exact piece made again. So of course with 3D printing, you can 3D print any shape you want, right? So you can make these very easily. Another thing is, even if something potentially doesn't break, you might get new stuff in. So a lot of times facilities will have old machines, and instead of buying a new machine, they want to upgrade them with new safety features, new sensors, turning their old machines into, you know, what's as good as the new machine. So, you know, custom bracketry for that can be really useful. And the thing with brackets is they're low priority. So I assure you, if you're in a manufacturing facility and your internal machine shop's real busy and they've got 2-week lead time, and you go up and say, hey, can I get a bracket for a new sensor? They're gonna go, look, we got a whole bunch of really important stuff on our list. We'll put this on the list so you can get it in 2 weeks. So with 3D printing, well, if you're making this out of a composite, like this handle here, you could probably get your bracket in the same day. If you make it out of metal, it takes a couple days. But again, compared to the lead times you're looking at against it, that's even a couple days can be a real benefit. So next, I want to show you guys how we take apart and how we upload it into our software. And I'm going to show you guys how to print a part in metal. Okay, so the first thing you need before you can 3D print your part is what's called an STL file. An STL file is created from your CAD software. So using your CAD software, probably SOLIDWORKS is the best one, but there's a number of them out in the market now that you can use. You model your part, and then you save that part as an STL file. And once you have that, you upload it into what's called your slicer software, and that's what I'm showing you how to use today. This is the one I work with. This is called Eiger. This is for the Markforged 3D printing systems. It's proprietary to that. But this works similarly to a lot of other slicer softwares. And what the slicer software does is it actually slices the part. Think of it like slicing deli meat. It's the same thing. It takes a big part and it breaks it down into little slices and layers, so that way the printer has the instructions it needs to build it layer by layer. So let's see what that looks like. So first, you import your STL file, which you find on your computer, just like any other file. And here I've got the herringbone gear, so we'll use that as an example today. Then, once you have your part uploaded, you have to figure out which orientation you might use, because that's going to affect the part greatly, depending on whether you print it standing up tall, laying down flat. That's going to change which way the layers go, and that's going to affect the strength of the part, how fast it's going to print, just about everything. So this software I'm using right now is Cloud. That's why it's taking a moment here to load. And as soon as it's loaded, we'll take a further look at the settings here. Some of those include what material you might want. We're going to do ours out of 17-4 stainless steel, but perhaps if this was a part in the field, you might want to make this out of tool steel so it lasts longer. We've got Inconel 625, pure copper, a number of different tool steels, and the stainless we work with is 17-4. So that's what I'm going to print this part in. And I see that it's red, which means we have a little bit of an error, which I think is because it might be a little bit too big for our sinter, so we're going to switch to the different sinter, and now it looks like we're good. Okay. So the next thing we can do before we print, we want to look at this in the internal view. The internal view is like an X-ray. You can see through your part. You can really see exactly what it's going to do with any support material that you might be building. That's what you see here. On the bottom, there's this yellow raft. This is an actual piece of support material that the part is going to print on. And the reason why we do that is because when the part goes into the sinter furnace and it shrinks, it gives really good contact between the part and the sinter plate, so you get really uniform shrinkage. And that's what you want, because you want to come out with the most accurate part. But you have your part in this internal view. You go into 2D mode, so you can look at it layer by layer. And at this point, I just click through the layers. I just looking for any irregularities, anything that might give me pause. But
I know the geometry on this part is fairly simple, so I don't think there's anything in here that's going to give you pause, but it's just a great part of your process to go back and just take one last look before you hit print, make sure everything looks right. So that's what I just did there, and then we'll go back to the 3D mode. Go into our part view. We've got some settings here, so this could be resolution or altering your supports or maybe controlling the density of your part. One great thing about 3D printing is that you can build a part with infill, so the inside is more hollow than the outside. And with that, you get a very lightweight part. And this is great for, anything. I mean, some parts you're going to want them solid, you just want a little extra strength, but definitely for end-of-arm tooling or applications like that, lightweighting is really key. So something you might want to think about. This part I'm going to leave at the triangular infill, which is the default setting, because I'm happy with that. And once you get your part settings all ready, you hit the print button. And now it shows the part on the print bed, and you can actually take the part and move it around anywhere you want. If I wanted to add a part, I could add a second one, or maybe I even want to add a different part. So you can add as many parts as you want. Move them around, get them where you want them on the build tray. And that's about it. You pick your printer, and you hit print. And I'm actually already printing something at this moment, so it doesn't give me the print button, it just says add to queue. If I wasn't, it would offer me the print button, and you hit print, and away you go. And that's how you print some MRO parts. Thank you so much for watching. Really appreciate it. Thanks, and hopefully I'll see you guys soon. Have a great day.